Your sense of smell, so it gives you a sense of richness and pleasure and things like that. You get pleasure out of things smelling nice. Okay, yeah, cool. So just for smell, what else? For pleasure. Danger if you smell smoke, yeah. I smelled smoke last night. The girls and I were talking and then smelled smoke. So what do you do when you smell smoke? Well, I went out and I looked for the fire. Yeah, that's right. I walked out in the street and I walked in the backyard and I sniffed and looked. Why isn't smelling enough? Why did I go and have to look? Yeah, but why can't I work out if it's just a barbecue from my nose? Why do I have to use my eyes?
It's not that sensitive.
You know, we're pretty pathetic, aren't we? We're not dogs. There's not enough information. I mean, it's connected right to your brain. The nerves from the olfactory nerves, boom, they're into your brain straight away. It's pretty primitive, but it's not very good. So we use other things to work out what the problem is. Really, the smell's just an alert that says, oh, this needs you to go and have a look at it. And that's exactly what code smells are. There's not necessarily something bad. You need to go and use other senses and other skills to analyse the code. It's just there might be a problem here. Let's go and suss it out. All right, so that's smells. I went through a list of smells. What did I do? I went through the smells from the GO4 book. I did some of the smells from the Refactoring to Pattern book. And I also just said some smells that I think are smells. And you guys came up with a list of smells that you thought were bad too. What we need to do, I reckon, to be cool programmers is have a list of smells and have a good sense of what the smells are, and when we write code, we're just looking out for the smells. So to that end, I've created a smells page. I call it Student Smells. And I would like you guys, please, to write down on this page, link from the lecture note, every smell you can think of. And there could be low-level smells and high-level smells. And you're free to debate them or disagree about them, but put in a series of smells for good and bad OO design, please. That would be good. And you're welcome to also go and look at C2 and all the other sites to look at their ideas of what to smell, and you write down every smell you can think of. Now, we talked about your project then, and did I mention it's coming up to software version 7? Or what are we calling it? 2.3? Oh, well, thanks, Thurston. I haven't put my microphone on. Oh, I made a video, by the way, on the weekend I edited the video of Richard Vickery. So that's up, or actually, it's not up on YouTube, it's up on the CSE server. I'll post a link on the Stop Press, so you can all go and have a look at the interview with Richard Vickery. Some people asked if they could get that quick. I'm hoping to get Kathy's one up fast too. So it just takes me a long time to edit the things. Let me put this volume up. Okay, let's go. So, yeah, version 7, I'm expecting after this version that everything's going to settle down. So this will be the last of the old version 2-point-somethings. After the Dark Ages, you're going to come back with a version 3, and we expect that to have most of the features, and we expect 3.1 and 3.2 just to be tidy-ups. Okay. Just also a tiny bit of house cleaning. When we finished the last lecture, I was going to mention smells are bad things to avoid. I was going to mention 2 sort of positive things to aim for in your code, and I don't think I mentioned them. 2 things out of the Gang of 4 book. One is to program to the interface, not to the implementation. Did I talk about that? I did. Okay, cool. What does that mean? Program to an interface, not to an implementation. Good, excellent. You've warmed the cockles of my heart. Program to an interface, not to an implementation means when you write code that uses something, don't have it use a concrete class, just have it use a type. And then you're free later on to substitute other classes in instead. Yeah? So program, literally that would mean you would write your code so it uses an interface whenever you need to use something rather than using a named class. That gives you the freedom in the future to substitute different classes at the same time. That's rule number 1. And rule number 2 is favour object composition over inheritance. Basically, when you need to add new features to a system, you could create new objects maybe, and you want to reuse existing functionality to create these features. So you want to add something to the system. It's not completely new. It's just a different tweak on something you've already written. in a language like C, we might be compelled to rewrite the whole thing from scratch, introducing duplication, because a lot of it would be in common with things we've already written. So we certainly don't want to do that. I assume we're all starting from the position that we don't want to do that. In Java, though, we might be tempted to use inheritance and add functionality by inheriting everything from the parent class and just tweaking it a little bit. And that's a valid way, isn't it? That's quite fine. And that will add the slightly new bit of functionality and reuse the old functionality, so that's fine. That was sort of the objective of inheritance. But actually, that's not how most OO designers now think that OO code should be written. Instead, the current sort of way of thinking, and I quite agree with this, is where possible use existing objects and just compose them together to get the new functionality. So one way of doing that is the delegation thing we looked at before. But basically, rather than using inheritance to extend something and adding some features, try and find things that have those features in and compose them in some way to get the new functionality if you can. Yep. So they're the two sort of general design principles from the Gang of Four. And why am I doing this? Because this is our last lecture on the Gang of Four and all that stuff. We're about to flip into algorithms next lecture, so I'm just trying to finish everything off, cover all the bits and pieces. I think that's the only thing I haven't talked about that I wanted to talk about. Okay, so my plan for today's lecture then is we're going to look at some of the actual patterns in detail, and we'll look at refactoring to a couple of the patterns. And we don't have time to look at all or even a large range of the patterns. There's just too many of them. And I'd like to do a few in depth rather than touching on a whole lot. So I'm going to limit us to creational patterns. They're the patterns to do with creating new objects, because that's sort of interesting and it's an easy bad smell to have in your code. Creation sort of tempts us to do bad things sometimes. So we'll focus on creation. Why do you think creation, using new, something like that, why do you think object creation might be regarded as a dangerous thing or a bad thing? Why is it an area prone with traps for young players, sort of thing? What about creating an object? What about a constructor is different to a normal method of an object? What sort of traps could you fall into as you write your constructors? Yeah.
Presence of a default constructor.
Oh yeah, so there's a whole lot of rules, aren't there, that don't come with normal constructors. So you've got a default constructor if you don't give one, and if you do give one, then then you don't get a default one. There's a funny use of super, the super constructor, and all sorts of funny rules about how to use that. That's right. So there's a whole lot of language rules hanging around constructors, and I guess in a sense that's a smell to tell us, whoa, there's a lot of complexity hiding here, and you could easily make mistakes there. I hate any form of complexity, so that's a bit of language complexity. And that's the sort of thing that I gave you a little quiz about last week. That's where the area where quizzes will be. They'll all be about inheritance and construction and things like that, because that's when you need to know the fine little implementation rules of Java to work out exactly how the thing behaves, because there's a lot of complexity there. We don't like complexity because it's just asking for trouble, isn't it? Okay, yeah, so there's funny rules with defaults. Yep, good one. Something else about constructors. It might be bad. Well, not bad, but might just be a bit dangerous or lead us to do bad things or something.
The fact that you can have like multiple constructors as long as they just have a slight difference in like the inputs.
Yeah, so you can have multiple constructors. So you can have, that's called overloading. You're overloading the method. You can have multiple ones distinguished only by the type signature of the input arguments. Yeah, that's right. Now you can do that with normal methods too. But yeah, I agree. It is something that's a little bit worse with constructors. Why do you think the problem's a little... And that's confusing. That's our problem, that it's confusing. If you've got multiple methods with the same name, maybe you'll call one thinking it's another one because they've got the same name. You've only got the parameter list to tell them apart. So that's rife for error too, isn't it? You might have the wrong mental model of what the constructor you're calling does. Why do you think that you might have overloading for constructors more often than you'd have overloading for other methods?
For a good reason. For example, you want to insert a mock object or something?
Yes, you might want to insert a mock object, so you might need to have override the constructor. You might need to have two different constructors. That's right. In fact, that's the answer, I reckon, that you might need to. With other objects, you never need to overload them. With other methods, you never need to overload them, do you? If you want to have two things to create a maze, you could call them both create maze and give them different arguments, but there's another option available to you, which is
create maze A and create maze B.
Except don't say create maze A and create maze B. You'd say create a two-dimensional maze, create three-dimensional maze. You know, you could give them a meaningful name to distinguish about, so you're not going to get confused. But with constructors, not only we can't give them a meaningful name to distinguish with, we can't even give them a meaningful name to start with. Yeah, there is no name. We have no ability to name them. So if you want 6 constructors, you're going to have to overload them all. You have no choice. There's no other way. So that's a pain. So you're more likely to be overloading on a constructor than anything else, I reckon. And when you do, it's confusing because they all look similar. And you could even have this problem that you could have 2 constructors doing different things which take the same type signature, and you're not allowed to overload. Like, suppose you've got to somehow represent 2-dimensional space. You could have an initializer for points in 2-dimensional space. You could have a point constructor that gives x, y coordinates to create it. And you could have a constructor that gives, you know, angle and distance, polar coordinates to create it. And they're probably both taking in 2 floats. So from the type signature, you probably can't even distinguish between them. So that's a pain. It's sheer coincidence if all the different constructors you want happen to have all different type signatures. They may well not. So that's a problem. So yeah, we're more likely to overload, and overloading is just asking for trouble. Someone asked me before why I didn't like overloading. I don't like overloading because literally it is overloading. You've got one name which has some meaning in your head, and you're using that thing to mean multiple things. You're just asking for trouble. It's like you've got something called an eject button in an aeroplane. You don't want to have something that serves the coffee that's also called an eject button. And you can say, no, by context I can work out which one you want. Yeah, maybe you can, maybe you can't, but can you see you're just asking for trouble. You're just putting extra cognitive load on the person using the damn system. So give everything a different name. Don't overload. Like in Java, we have this cute thing that you can use plus to add 2 numbers together, but you can also use plus to concatenate 2 strings. And that's sort of cute, isn't it? Oh, we like that. We think, joining 2 strings together is like plus. But no, it's not. It's not like plus at all. I mean, it's an operation on a group that has some of the properties that plus has. But, well, it's not. No, for example, 6 plus 2 equals 2 plus 6. Yeah. Plus, I'd expect to be symmetric, and concatenation is not a symmetric operator. I mean, it goes from string to, plus string to string, but it's got the right type signature, but it doesn't behave exactly like plus. It's just done for cuteness. There's no reason they couldn't have used another symbol to do it. They just did that, and I reckon the 2 uses are so dissimilar that we probably won't confuse them, except it can get confusing because you can add an integer to a string, can't you? And that'll convert the integer to a string and then concatenate them. And maybe you make a mistake and you don't notice one of the things is a string because it's got a name, because that string is representing a number, and you think you're actually doing an addition and you're not. You know, you can see there is room for some error. So I don't like overloading just because it's overloading my brain. I don't want it. I want everything that's different to have different names or have some sort of really clear way that I don't mix things up the same. Going on and on about overloading. There's more to constructors than the overloading problem. I'd say one big one is the naming problem, that you can't name the constructor. You make the thing, but you can't give it a meaningful name to say what you're doing when you create it. Java doesn't let you use a name. It just forces you to do it. Also, if you allow people to create objects, you're sort of giving them the keys to the kingdom. In a sense, if you have some really flexible constructor that takes in a range of arguments and creates an object and then sets internal variables to those values, if an idiot if someone outside, if it's a public constructor and someone in the outside world can create one of your objects, maybe you've got some sort of implied semantic contract going on here that all the values have to have some sensible relationship to each other, but you're just giving a default constructor that just does a whole lot of setting. Someone might call it with an invalid set of arguments. In other words, people might not know how to construct a valid object. They might abuse the constructor. It might be possible to construct invalid objects using your constructor. And then that's just dangerous. You probably want to control who can create objects and limit it to people that know what they're doing. I mean, that's why we have sex education at school, basically, isn't it? So, yeah. I'm very interested in sex education at the moment because I was renovating my house and I found under the floor some old newspapers from 1972. And I thought, oh, cool, I can look what 1972 was like. It's like a time machine. And I got the papers and was reading them. And it was all about sex education because apparently then, or maybe it was 71, apparently then that was when it was being introduced into schools in New South Wales. And all the papers are guffawing about it. And they're all talking about it. And it just seems so ludicrous to read it now. So it was very funny. Particularly my favourite one was where they talk about teachers told to teach, do as I say, not do as I do. That was the advice to teachers. I'm thinking, that never works as a teaching method. Yeah. I don't think anyone ever falls for that. You know, teacher saying, I don't do that, but you should. You know, that just doesn't work. What daft advice to a teacher that is. Okay, okay, so yeah, we don't like constructors for a whole range of reasons. Also, because you might want to construct various different flavors of an object, and they're probably, because you're all constructing an object, it's the same object ultimately, they're all related in subtle ways. There's presumably some common property that all instances of these objects, regardless of which constructor you use, have in common. It's quite likely when you write multiple constructors that all the constructors could have overlapping bits of code. It's often the case that you might have 9 constructor, well, it's not often the case you have 9 constructor methods, but if you did, it would be likely that lots of those constructor methods would be having common chunks of code in them. And that's duplication, and we don't like that. So there's a whole range of reasons for not liking it. Objects create us, it might not know about it, so you require other objects to have knowledge of how to create an object and what a valid object makes, so you're creating dependencies between objects, not isolating us. I know another one. Here we go. In the 18th century, this awesome Austrian guy, whose name I can't remember, I should go and Google it. I'll Google it in the break. Made this machine called the Mechanical Turk. Has anyone heard about the Mechanical Turk? I thought it was pretty appropriate to be talking about that today. The Mechanical Turk was a chess-playing automaton. It was like a big box with a machine that was like a statue of a person with a reasonable-looking face that stood behind it that had arms, and there was a chessboard on the table. And you could sit opposite the Mechanical Turk and make moves on the board. You'd put normal pieces on the chessboard, and it would reach its arm out, pick up pieces and move them, and it would win. And this was in 1770. And it would beat the world's players, like awesome players. Also, you could ask it to do a knight's tour. You know, that's how you do a sequence of moves with a knight that covers every square on the board and then eventually ends up where it started from without any duplicates. And you could put a piece on any square and say, do a knight's tour, and it would slowly pick up the piece and move it around. Now, that's awesome. You guys probably couldn't even write a program to do that, right? Well, maybe you could now. But in 1770, could you have done it? Using clockwork? Also, when it got in check, it would say, check. And if you made an invalid move, it would reach out and pick your piece up and put it back in the right spot. And you fought for the move. It was an awesome thing. And the guy just travelled around Europe and everyone loved the Mechanical Turk. Now, the Mechanical Turk, he was very careful, although it had drawers in it, it was on a table. Does anyone have a picture of it? Yeah. Can I have a picture and I just show everyone the picture?
It's very small.
Oh, that's all right. I can zoom in on it if I just put your laptop on the document projector.
If you click it, get bigger.
Don't worry, I'll fix it up. Oh, yeah, okay, that's an awesome picture. All right, thank you. All right, here's a Mechanical Turk. By the way, what I'm doing now is called the adapter pattern. I've got to turn that light off. Oh, sorry. How's this go? Oh, and it's hopeless. I'll show you later on, guys. Can I just leave it here for a sec? Is that all right? I'll show them when it warms up. So what the Mechanical, it was like on a table, and it had little drawers you could open up, and inside they had all this clockwork, and you could see right through to the back, sort of thing, from opening doors, and it had doors all around. You could open them all up and look underneath, and then you'd play with it. Now, the guy that owned it, has anyone got his name? Oh, maybe that's on the page you just found out then. What's his name? Oh, you don't? Does anyone know his name? Von something. Oh, it's working. Oh, thank you. Here we go. Can you see it? Let's zoom in. Hang on, there's a focus button. Okay, that's it. That's an engraving of it. It was actually pretty precise engraving. I seem to remember if it's a famous one, because the person that did a lot of the engraving was actually an obsessive person. He put a ruler on some of them. There we go. So it sits on this table. You can open all those drawers and look through. You can open the drawers on the side. You can open the doors at the back. The thing just bloody well moves the pieces and plays an incredible game of chess. It's fantastic. Now, how people could interact with it was in a completely abstract way. You weren't allowed to know what was going on. The guy that invented it wouldn't let you know how it was going on. And he always had to be there when the thing was playing. But he let you put magnets nearby it, powerful magnets nearby it. He was prepared to put his hands behind his back when it went and so on and so on. So it wasn't trickery or anything like that. But you could only interact with it through the interface, which is you'd pick up a piece and move it, and it would move back. So that was the only way you could interact with this object. Now you can see it could be an object, couldn't it? Yeah, and it could be in a class. And later on you could think of other ways of making the Mechanical Turk. Maybe you'd replace the clockwork machinery inside with something better, or you put electronics in or something like that. And the people using it probably couldn't tell the difference. So it looks just like an object in that it has an interface you can interact with. It's perfectly encapsulated. The outside world doesn't have to know how it's implemented. So we liked the abstraction, we liked the whole thing, and everyone was amazed because they were, of course, all trying to break abstraction and work out what was going on inside it. I'm going to use this to show you why constructors aren't necessarily good for abstraction. Because what if, when this guy whose name I can't remember, I'm sorry if anyone here is Austrian or... Von Kempelen. What's his first name? Wolfgang. Wolfgang von Kempelen. Suppose I'm him, because that would be awesome. And I'm going to make the machine. I need to make a new one. Yeah, it's a new constructor. I shut the program down last week. We're making a new one. If you just use the interface function, you don't know anything about what's going on inside. But I say to you, Theo, my man at the hardware store, I'm just about to run the constructor to build this machine. I need to pass into the constructor a small dwarf who's very good at playing chess, a sliding seat that fits inside the cabinet and can slide from side to side, a series of doors that you can only open one at a time, a series of magnets underneath the chessboard that rise and fall when pieces are placed there, and a series of normal-looking chess pieces with magnets on the bottom. Can you see, by telling you the constructor, I have slightly given away some of the implementation details? So constructors leak implementation. This is why, if you have an interface, have you ever noticed it? Interfaces can't specify constructors. If you want to specify a constructor, it's not in the interface. So if I implement some interface, I've got to also work out my own constructors. I can't force people to use... It's because constructors and instructors are implementation details. They're not abstract details. And when you inherit from someone else's class, you don't inherit their constructors, you have to give your own constructors. If you want to reuse theirs, pass back to them, you've got to explicitly do it. That's because inheritance, interfaces, these are things for abstraction. Constructors aren't abstract. So we also don't like constructors because they're sniffing around the edge of implementation. They're not really abstract. If I want to make a new thing, if I want to make a Mechanical Turk, and I'm a user of Mechanical Turks, and Mechanical Turk is a product, I shouldn't have to know how to make it. I shouldn't have to know any implementation details. I should just be able to say, give me a Mechanical Turk. Yeah. Okay, so for all these reasons, constructors are sort of on the edge of what we like, and there's a couple of patterns to deal with constructors because there's some bad habits you can get into with constructors. There you go. Thank you very much. By the way, of all those things, the awesome thing he did was he actually did get it to speak and say chess. And the reason he's remembered today isn't for being a Czech. The reason he's remembered today isn't for being a charlatan. It's because he did awesome work in simulating vocal cords and getting mechanical devices to talk. How about that? Awesome guy. And he did it by just mimicking. He tried to model the human. Yeah, he's so everything about him's Okay. All right. So let's look at a couple of different things about constructors. One thing about constructors is duplication in code. I now have logged in. Let's look at some of the refactorings that come in with the refactoring to pattern. Ah! Oh, sorry, what did you say? Screen. What a funny man. Yes. I see what you're doing there. Okay. All right, where are we? Designing algorithms and data structures. Well, that's tomorrow. Oh, some people are writing their notes as we go. Awesome. Are you ahead of me? Can I just read these out? Well done. Some beautiful poems. A poem to a dog. Yeah, very, very good. Okay, here we go. Here's some code. It's just actually from the Refactoring to Patterns book, from the Refactoring to Patterns website. This whole lecture is sponsored by Refactoring to Patterns. I get 10% of any sales made. Please mention my name. Okay. So, I always forget I can do this. So here's I wonder if I can view that image and make it bigger. Does it, if I go Control Plus, I can make it bigger? All right, here we go. Here's a loan class, and there are 3 different sorts of loans you can make. You can make a revolving something, I don't know, they're all different sorts of loans. This is Macquarie Bank talk. You can make this sort of loan, and you can make this sort of loan, and you can make this sort of loan. And I'm in some sort of company that sells loans to people. Now there's lots of things in common, but the loans have little fiddly details that makes them different. So looking at this code, hopefully you're going to see that the first thing we don't like about it is it's about a corrupt capitalist system. Yes, but what else?
Way too many parameters.
Way too many parameters? Yeah, now why is that a problem?
Because it's complex, not really.
It's complex, and why is that a problem? No, tell me, you're right. Why do you have a sinking feeling when you look at that?
Well, I mean, I just look at it and be like, oh, where am I going to...
Yeah, you don't understand what's going on. You don't know what's going on. It's very hard to understand, so it fails the clarity test. Would you say that? The complexity is actually quite scary. All right.
They all look exactly the same.
They all look the same. They've got duplication. What do we think of duplication? What do we think of duplication? Yeah. So what can we do? There's a standard way of fixing this problem that people do. This is our first refactoring. It's a baby refactoring. Call other constructors. It's called chain constructors. So link your constructors together and pull the duplicate code out. Now, if you had to simplify these and chain the constructors together, so one constructor calls another, calls another, calls another, as required, how would you do it? How would you actually do the refactoring? We know what we want at the end. We'll end up with one sort of constructor that is reasonably complex and presumably quite flexible, that does most of the work, and then a couple that do slight parameterizations on that and then call that. So we know what it'll look like at the end, but how would you actually get there? What steps would you go through? Now, I reckon there's 2 ways of doing it. One is you can just use your very, very clever brain and look at it, and pull it all to bits, rebuild it so it looks nice, and then test it. And you're very, very clever, so good on you. But what am I going to say is not good about that approach? You can make mistakes because you're not making, like what sort of steps are you taking? Big steps. And what sort of steps do we want to take? Tiny steps, baby steps, that's right. Okay, so the Refactoring to Patterns book, which I really love, the reason I love it is it says, it's just got a whole lot of recipes. Now you might think programming to a recipe, that's horrible, I hate that, that's not why I became a programmer. But no, it's just moving all the crap into the recipes so you can use your brain to do the amazingly fun things. I did see a post on the internet as I was browsing around recently of some poor kid. I often find web pages of people who have taught themselves Java, and then they post little tutorials up to help other people learn Java, and they're all in high school or something like that. And then they're trying to explain it. I think it's really interesting. I love looking at that because it sort of shows what people think is hard and what misconceptions people have. And students explaining things to students, I think, is a good source, good thing for teachers to look at. So I look at it all the time. And then often I go to the bio of the kid and he'll say something like, oh, and I'm hoping to go to Harvard, or I'm hoping to go to MIT, or one of those things. And I always think, oh, and then I track them because they made this post in 1997. And you go and look at their website now, and they didn't go to Harvard, they went to New York, TAFE, and they didn't that, and now and it's just really sad going through this thing. And I found one recently, and it was this kid who was so enthusiastic, and I started reading through his blog from years and years ago, and he was so excited, and he loved programming, and then he started going to sites to teach himself programming, and he went to the MIT site, and and after a while he said, oh, I don't think I like programming anymore. I just don't think, it was much more complicated than I thought it would be, and I think all my code's crap and no one will ever like it. And it's all just all these rules and things, and it's boring. And I used to find it this great adventure, and now all these rules I have to follow, and it just sucks all the life out of it, and I don't think I like it. And it was just the saddest thing I ever read. So I just wanted to say, if any of you are feeling like that, A, good on you for not going to Harvard or MIT. Excellent. Okay, because Australia rules. Yeah. 2, no, that's 2 as well. 3, don't ever think computing programming is boring or lose heart. And if that's happening, take a big rest, go for a walk, go and watch a movie or something like that and come back later on. Because it's awesome and fantastic. It's just that there are boring bits in there. Let's try and get them out of the way as easy as possible, delegate them to other people, delegate them to automated tools. Don't enter into problems that involve those. Okay, but the things that are left, once we get this boring crap out of the way, are so awesome and amazing, much more amazing than the things you used to do when you taught yourself, that you will have pleasure for all of your life doing programming. It is so cool. So, all right, I like reading the Refactoring to Patterns book because as this is the example from the book, he gave me a series of mindless steps to follow whenever I see this, and I can just follow them without thinking. And the nice thing is all the gotchas he's ever discovered or anyone else has ever discovered has been written up there. So I can now share everyone else's experience and look out for common gotchas. So the actual technique, for the actual steps he went through in low-level detail for refactoring is he says, step 1, find 2 of them that look similar, where you could possibly rewrite one of them to call the other. So there are 3 of them here. He said, don't worry about that. Find 2 that are similar. And then he says, rename one of them and get it to call the other and just put the extra bits in it. That's step 2. So you now have one basic thing that calls the other one. And then he says, rewrite and make everything beautiful. That's the next step. And then he says, run your tests again. Because every time, oh sorry, run your tests again. I missed that step before, didn't I? Before you did the make beautiful step. You run your tests again. So you just make 2 of them, one call the other. Run all your tests, check everything works, make it all beautiful. And then repeat. And you just keep iterating. I mean, it sounds so mindless. I picked it because it's the easiest refactoring. You know, it's just nothing happening. But the idea is you just do it pairwise, step by step by step. And if there's 5 of them up here, it'll take you 4 steps to do it. And you run your tests after each one. And then when you get to the end, and this is what I got excited, I was looking at that thing, oh, they're very simple steps. I could have worked that out by myself. I guess I'd have tried to do them all simultaneously. But now he talks about it. Yes, that is a good idea to just get one happening at a time. That's really good. But I could have worked it out myself, so this book's pretty stupid. But then he got to the step at the end, and it was something I hadn't thought of, which was, what do you think you do at the end once you've done all this? Add another step, which is, see if you can find any constructors. Oh, I can't remember the step. Damn it, I wish I had that book here. I left it in my office. It's something like, I know the outcome of the step. It's something like, see if you've got any outside methods that call this constructor. See if you can now rename them to call the more general constructor you've just built. Does that make sense? Because you're ultimately going to end up with one very general one and a whole lot of little guys calling it. If anyone's calling one of those little guys, and you can make it call the big one, get it to call the big one, and if you can do that to everyone that calls this, and this is the exciting step, what do you do to it? Make it private. Yeah. Or maybe you've got people calling the complex ones and they can call the little ones. But what you try and do now is you work trying to stop people calling them, trying to get them to call common ones. And whenever you manage to stop people calling the one you're using and nowhere in your code is it called, you lock it down and make it private and you run the tests again. So what you're doing is you're reducing the exposure to the outside world of the innards of your class. So it was really nice. All right, it's a very, very simple refactoring. All right, let's go back. Let's look at refactoring number 2. So that's called chaining constructors. It's not very exciting, but it's good first step. Step number 2, that gets rid of duplication in construction code. What about the fact that construction code is complex?
Duplication make it more complex?
What's that?
If you're suggesting that instead of calling the little constructors, you call a bigger constructor, naturally you're going to have some method of differentiating.
Yes.
Which would happen in
Yes. Good question. And $50 million to you for not just believing everything I'm saying, but questioning what I'm saying, because that's absolutely fantastic. I love it. You've already left the Dark Ages. Yeah, the church says everything revolves around the earth. And you say, but I say, I've taken some observations. It sort of looks like things revolve around the sun. Oh, good question. I now have to kill you. Lock you under house arrest for the rest of your life. Yes, that's a good question. Will chaining them necessarily make it less complex? We were thinking, will it we get rid of duplication, but may that make it more complex? Might it be, now rephrase your question again, that if you end up with a more sort of catch-all constructor at the end that can do everything, if you ended up with that?
It needs to know what other constructors to call, and therefore the user needs to specify to the general constructor which specific constructor they want, probably through a parameter.
Okay, so we've got this problem that we might have removed duplication, but we might have increased complexity, because now it might be quite hard for the user to work out which one to call. And now they might not make as much sense as they used to make. And now you might have very general purpose ones with lots and lots of arguments you have to supply and fill in. So the complexity here, I think, is coming from a lack of encapsulation or increase in coupling, which is objects that create you now need to know more about you, or now have a harder job. Their job of creating you is made more difficult. Yes. So that first refactoring doesn't solve that problem. And the refactoring we're looking at now, which you normally run immediately after doing that refactoring, now is to get rid of complexity. Now, it's not going to get rid of complexity completely, because maybe it is complex to make these objects. We can't make something that's complex simple. But what it's going to do is it's going to move. Who should have to deal with that complexity? Who should have to know all the difficult aspects of how to create an object? The object, that class. Not people that need to use that object. They shouldn't have to know about it. The object itself. We should centralize it. Yeah, that makes sense to me, at least. I mean, I'm sure you can think of counterexamples where that's not the case, but I would think normally that that is the case. Leave it up to the object to know about how the object is made. So you could have complex construction methods, and you could have many of them, and they can't be named, and you've got all sorts of crap overloading going on. And overloading has all sorts of limitations on it too, which is interesting things about widening and changing from private to public. You know, like you try this. Try and override a method with another method in a subclass, and try changing security modifications and see when the overriding's allowed and when it's not. Like, can you override a public method with a protected method? Can you override a protected method with a public method? Can you override a public method with a private method? What the heck is going on here? Okay, so all these complexities. You think, wherever there's complexities, oh, that smells, doesn't it? So you go and look, I'm going to put that in your quiz for this week, overriding different security classes. Okay, modifiers. Okay, so the second refactoring we've got is replace constructors with construction methods, creation methods. What did I call them? Creation, construction methods. So instead of saying new maze, argument, list of rooms, argument, list of connections, argument, list of walls, argument, list of doors, argument, list of magical items, close brackets. Instead of having a constructor like that, which is a new thing, I'm going to give my mazes a named construction method. I'm going to name them. I'm going to make a method, and what will I call it? That sounds to me like make magical maze. So I'm going to have a method called make magical maze that takes all those arguments in. And it's not a construction method. It's not like a new. It's just a method. And that method is going to return something of type maze. And it's going to return a new one. How's it going to do it? It will call the constructor itself. Does that make sense? So you in the outside world wanting to construct an object, call the named method, the construction method. Inside the object, that method calls the constructor and builds the object, and it's returned. And you can imagine how this technique is going to work. The first thing is to chain. So before running this one, you always chain them together. Then you give them sensibly named for commonly made objects. And if you find out all your objects are commonly made, you can actually have a complete set of construction methods. And that's the best if you could do that. And then as soon as you find a common usage, like 50 objects that use this, 50 clients that need objects built this way, or build the object this way. So you go, okay, I'll take those 50 bits of code which are very, very similar. I'll put them inside the object itself. I'll give it a name. That's a creation method. I'll get it to call the constructor in the way that these objects used to call the constructor. And now what do I do? Now I've got the creation method happening inside the object. What do I do now? What do I do to all the clients that used to call the new function? I now get them to call that method. Yeah. I run the tests each time after I do it. I run my unit tests after each change. And now those clients are all calling the construction method, which is a named method. And now those clients make sense. They don't need to know about the knowledge. The named method presumably is giving more information about what's going on. And what were you going to say?
Make the original constructor private.
And if no one in the outside world now uses the constructor that you've now inlined inside your code, then what are you going to do to it? You're going to make it private. So you're going to not let people make your objects. They can only make them by using your named method. And you iterate that over every common pattern. And if you're lucky, you can make all your constructors private. Wouldn't that be awesome? Because if you can do that, then you've encapsulated all knowledge about how to construct an object into the object itself. And that is what we call a construction method. And we love construction methods. Is that cool? And does that address your concern from before? Does that address your concern about complexity before?
maybe it just works.
Now ask me your confusion, because if you're confused, everyone's confused.
A method of an object when the object doesn't actually exist yet.
How do you call a method of an object when the object doesn't exist? It have to be static. Yeah. Or you have to ask another object to make it.
I guess.
Yeah. If it's a static method, then it's a class method, and the class can call it. Or maybe there's another object, and then it can make it. Yeah.
That's still a bit of a problem.
Yes.
You said when you had the public constructor, you're passing in a ridiculous
Yes.
list of arguments.
Yes.
What happens to our new method? Are we still passing it the ridiculous number of arguments?
The new method needs all the arguments that need to be passed to it. So presumably you can derive some of them internally, if you can, if they're internal duplication, you can do it. And if you can't, then presumably all that information is needed. But that will make sense to the outside world. Because if you're saying, I want a new magical maze, then you have to supply as arguments everything that a magical maze would need. And that makes complete sense. But you shouldn't have to supply other things that it's not obvious that a magical maze needs. So I have no problem with you having to pass in an enormous list of 50 things if it's clear to me that a magical maze needs those 50 things. Yeah. Are you worried about what I was talking about, the Magical Turk?
No.
No.
I'm just trying to see the difference between creating the object through the constructor,
Yes.
using all those arguments, and using the method to...
Yeah, so what's the difference between, that's a really good question. What's the difference between creating it with a constructor, which has a ridiculous number of methods, and constraining it with a name creation method that has a ridiculous number of methods? Clearly the difference is not the ridiculous number of methods. We haven't solved that problem. But there is still a difference, I would claim, and it's much better. Can anyone think what it might be? Why might it be better to use a name constructor rather than a name construction method rather than using a constructor? Even if there are a ridiculous number of arguments.
It has a better name.
It has a better name? Where are you gone? Was it you? Was it, who asked? I've forgotten. Yeah, it was you. Yeah. You didn't put a coat on or something while I turned away. Yeah. Goldfish Richard. Yeah, so
it's clearer when you're like writing it through
Yes.
code. You can go, I want to create a magical maze. Then you create.
yes, you say, I want to create a magical maze, rather than a long list of parameters that imply you want a magical maze. And remember when I gave those parameters before, I said the magical stuff at the end? So you'd actually have to read to the whole end of the line going, what the hell's he making here? Yeah, it's got rooms in it, it's got stuff in it. Oh, it's got magic in it, he's making a magical maze. But you wouldn't know till the end, it's all complex. Whereas now, the name says it all. Furthermore, the details for how to actually make it are now inside the constructor itself. So if there was work to be done before to construct it, you no longer have to do it. Like, for example, suppose the constructor needs a list of all the rooms and the number of rooms, and it needs a list of all the magical rooms, and then the number of rooms that are allowed to be magical, and it needs a list of all the fairies, or something like that. So before, when calling it, you probably go, well, in a magical maze, my idea of what a magical maze is that the number of rooms is exactly equal to the number of rooms I tell it, so no more rooms can be added. It's not a dynamic maze. And I would like it to be possible for every room to be a magic room. That's what I think of a magical maze as being. So I'd say pass in the list of rooms, pass in the length of the list of rooms, pass in the list of magical rooms, they're the rooms that are currently magic, passed in the length of the original list of rooms though, because I'd like them all to be magic, and I don't have fairies in a magical maze, what a ridiculous idea, pass in an empty list. Yeah? Because that's what, to me, a magical maze is. Now, I had to do a whole lot of work in thinking about what a magical maze was to pass those arguments in, because some of those arguments were derived from other ones. So now, inside your method, you'd go make a magic maze, here are the rooms, and here are the rooms that are currently magic, and inside the method it goes, oh yeah, and I know a magical maze is one where any room can be made magic, and it will now do those length operations, and it will pass in the empty fairy thing. Does that make sense? So there is normally a bit of logic around a construction method. You generate a few things before calling the constructor. Now, hopefully you don't have to do that. Hopefully you're now just passing in the atomic data that is needed to make a magical maze, and all the details are worked out by the system. But even were that not the case, even were you originally miraculously calling a constructor that exactly required exactly what you would expect a magical maze to need, so there's no shortening of the list of constructors, you've now got a named guy, and that's awesome. Yep. That was a very long answer. But is it a compelling answer? Can you just see we've reduced the complexity a little bit in your code now by having that word magical maze appear?
It should also hopefully be more difficult to put invalid arguments.
Well, hopefully, yes. If there's validity checking and things going on for a magical maze, I can now put it in the magical maze method. Before, my only option was to do it outside in the client calling, which doesn't make any sense, doing validity testing out there, or do it inside the maze itself. But now, the maze itself is sort of generic. I mean, it has to, that constructor might be called when people are making a magical maze, but that same constructor might also be called when they're doing a fairy maze. These are lame examples, I know. So there's different logic and might be different internal testing and things going on. So it's not necessarily the case that each one constructor constructs one type of thing. Normally there are many different products you can make by changing the arguments going into the constructors. The constructors tend to be more flexible in the number of products you make. So you would normally expect at the end of the day you have more named construction methods than you had originally constructors. Yeah. Whew. That was very long, wasn't it? But does it all make sense? So you've now seen two very, very simple refactorings. Important things to notice about these refactorings are tested every step. There's just a series of mindless changes to be done. I actually haven't gone through the detail of the book. Definitely get the book, Refactoring to Patterns, because it's so awesome. Here's the example for replace constructions with creation methods. Before, it used to say this. Before it used to say, I want a plus, this is not Java, it's something else, Smalltalk or something. Before it used, oh, stop that. Before it used to say in bigger letters, and now it does again, give me a new loan with a commitment, a risk rating and a maturity. Give me a new loan with a commitment, a risk rating, maturity and an expiry. Here are the constructors. Give me a new loan with a commitment, a outstanding, a risk rating, maturity and expiry. A capital strategy, commitment, a risk rating, maturity and expiry. It's like the Court of King Caraticus. And da-da-da-dum. That's what it used to say, but now it says, make me a term loan. There's two ways of making term loans. Make me a revolving line of credit, make me an RCTL loan. These call the underlying constructors in different ways, but now I know the sort of loan that I'm making by passing different parameters into the constructor. Yeah. Is that cool? All right. Let's...
Is the constructor now private?
Oh yeah, and now you'd make the constructor private. That's what the minus there means. Can you see now there's a minus in front? At the end of doing that, they found that was all the loans they ever made. They never called the constructors except when making those 3 different types of loans in those 6 different ways. So now they could get rid of all the constructors. Yep. Which is awesome, which we really like. And they chained all the constructors together first before making them private. If you go through the book, you'll see. Does that make sense? Are there any questions? Okay. All right, I'm now going to go through some patterns, but I think we'll probably take a break. I'd like to play, does anyone like System of the Down? What? No? So someone that said yes rather than someone said no, what song would be a good song to play in the break? Toxicity. Okay, all right, cool. All right, everyone, we've got a 5-minute break. Relax to this beautiful music.